Hello everyone, welcome back to my channel. Today we will solving the question kill Demodogs. Okay, let's just start by reading the question. Demodogs from the upside down have attacked Hawkins again. L wants to reach Mike and also kill as many Demodogs in the way as possible. Okay, so we are given something that there's a guy L who wants to reach Mike and wants to kill as many Demodogs as possible. Okay, now Hawkins can be represented as a n cross n grid. Okay, Hawkins is a place in this question. So okay, the number of Demodogs in a cell or at ith row and jth column is I dot j. Like if there's a column I of ith row and jth column, the number of Demodogs in it will be I into j. L is at the position 1 comma 1 of the grid and she has to reach n comma n where she can find Mike. Okay, the only direction she can move is I from I from sorry from I comma j to I j plus 1 and the down from I comma j to I plus 1 to j. Okay, she cannot go out of the grid as there are doors to the upside down at the boundaries. Calculate the maximum number of possible Demodogs. Answer she can kill on the way. Okay, so number of Demodogs she is killing is called answer in this. Okay, considering the considering that she killed Demodog in a cell which she visits. Okay, so she visits a cell and kills the number of Demodogs in it, and we have to multiply our answer into 2022. I guess this is one of those 2000 goodbye 22 questions. I'm not sure, I guess. So, and we have to modulate with 10 raised to power 9 plus 7. Okay. If you haven't studied modulo, I will teach you the basics in it, but I will suggest you to read it once again. Because the result can be too large, we have to never be gonna, because we are never gonna see. Yeah. Okay. So, we are given an input of test case T, where T is 10 raised to power 4, and the first test case contains one integer n, the size of the grid. Okay, so for each test case, print the number maximum denominator this and killed by 2022 modulo this. Okay, so first, like in the first case, we are given 4. Okay, 4 is the 2 is the first thing we are given. 4 is the number of test cases we have, like these 4, and 2 is the first we are given. And here we have given an answer which is 7 into this. So the answer here was 7. Now let's just start by first understanding the question. Okay. Wait a minute. Yeah. So what are the things that is given to us? There is first a number n given. Okay. Which is the grid. Okay. We have a grid of n cross n grid. And the other thing we know is that at a ith row and jth column, the number of Demodogs is I into j. Okay, this is something we know already. Now, I think we should first start by making a simple idea of when n is, let's start with a simple n is equal to 2. We know the answer is 7 in this case because it was given in our test cases. Now let's just first make the simple basic. Okay, I'm sorry for the bad diagram here, but okay, I think this might work. Yeah, so this place is 1 comma 1, this place is 1 comma 2, this place is 2 comma 1, and this place is 2 comma 2. Okay, now let's find the number of Demodogs in each of the following coordinates. At this, there is 1 into 1, that is 1. Here 1 into 2, that is 2. Here 2 into 1, that is 2. And here 2 into 2, that is 4. Okay. Now let's talk about how we can move. There are two ways we can move. Okay. There are two ways we can move. First, we can move right side. We can move at the right side. Sorry for the writing. We can move at the right side, or we can move up. We can move up on both of them by one block. Okay, why one block? Okay, see, by one block we can move either right or up. Okay, so we are starting at this position. Now we have to make a choice. But as you can see, both this and this is equal. So it won't matter where we are going. Either we can go here or here. Both will lead to the same answer. So we are going upside. Okay. Now after this, we have only one choice to go. We will go over here, and we will get our answer, that is 4. Okay, it seems pretty easy. All right. So let's just do it again. Like, let me just try something. Yeah. Let's just get a 4 cross 4 table. Yeah. Okay, how do we move this table? Okay, I'm sorry. Yeah. Yeah, we have selected the entire table. How are we supposed to move it? I'm really sorry for this, but okay, let's just leave it. Okay, let's just leave it. We will make our own table. Yeah. So there is this one. Okay. Just give me a second. 1, 2, 3, and this is total 4. 1, 2, and here. Okay, back. Let's just make it a bit big here. Yeah. So we have a 4 cross 4, which looks really bad, but I guess we need to solve the question, not really get on the design. Yeah. So now here, this is where we start. Okay, this is where we start. This is 1 cross 1, 1 comma 1, है ना? And this is, okay, sorry for that. Okay, so this is n is equal to what? 4. This is n is equal to 4. This is 1 comma 1. This is 1 comma 2. This is 1 comma 3, and this is 1 comma 4. Okay. Yeah, let me just make the commas. Yeah. Or you can, I think you can understand it in the normal way. This is 2 comma 1. This is 3 comma 1, and this is 4 comma 1. I guess all of you understand this. Now let's talk about what will come here. This is 2 comma 1, so it will be 2 comma 2, right? This is 2 comma 3, right? This is 2 comma 4, right? Now we will go over here. It is 3 comma 2, 3 comma 3, 3 comma 4. Okay, now here it is 4 comma 2, 4 comma 3, 4 comma 4. Now what do we see here? Okay, now let's just first make the how many Demodogs are in each of the box. Here there is 1, here there is 2, here there is 3, here there is 4, here there is 8, here there is 12. Okay, here there is 16. Okay, here there is again, okay, no, here there is 12 again, yes, and here there is 8, then 4, then 2 again, and then 3 again. Okay, you can see that most of them are already same, like this row, like this row, like, oh sorry, till this here, till this here, and this part, and this part. Okay, all of these are the same. Okay, because the coordinates of, if you're going in a 4x4 circle, the coordinates, the multiple of these coordinates will always be the same. Okay, now let's get in the middle. This is 4. Okay, this is 6, this is also 6, and this is equal to 9. Now let's think what we can do here. Now we are starting at this position. Okay, this is where we start. We have two choices to make. Okay, we can either go left or right. Both of them will lead to the same answer. So I think we should go above. We did go above. Okay, so we are at 1 comma 2 now. Now here we have two choices. Either take 3 from here or take 4 from here. And we need to maximize our numbers. So we need to take 4. Okay, So we move here, so we are over here right now. After this, we need to go above. We have two choices again, 6 and 6, so both of them are the same, so we can go anywhere, and I am taking the choice of going above. Okay, I am going above here. Now we again have two choices, either we can go for 8 or we can go for 9, and we know 9 is greater than 8, therefore we will go for 9. Now again we have two choices, 12 and 12. It doesn't matter which one we take, so I'm going to take the above one, this, and after this we can take the final 4 comma 4. Now you can see there is a zigzag pattern in this, and if you have ever done such type of questions, or you can just think about this type of questions, that whenever you see this question, you will think, you have to start thinking that there must be a pattern in this. Okay, usually with coordinates I have seen that there is a pattern, either I have seen it in maths or in when I have started it coding. Now we need, what we need to do is we need to find the sum of all of these values. That is there, that might be difficult for a lot of people. Now let's just get it. Rather than writing the total what we get from multiplying this, what I'm going to do is write the values, right? Okay, so like we have 1 into 1 plus 1 into 2 plus what is this, 2 into 2, okay, plus 2 into 3, okay, plus 3 into 3, okay, plus 3 into 4 plus 4 into 4. Okay, what can we see here? Do you guys see a pattern here? Like we are going in a zigzag way. So first we will increase this value, then we will increase this value, then we will go again, do the same thing over and over again. Now there was a chapter called sequence and series in class 11th, I guess, and in that you learn to see pattern in such type of equations, such type of you can say equations, yeah, let's just say equations. Okay, so the first thing you should know about this type of equation, it is called a APGP equation. APGP equation. Okay, like something is being multiplied and something is being added. Okay, so I guess the best way to solve this question is to go in a different path, and let's just start by differentiate, like let's just start by separating them. Okay, first let's just leave everything and start by writing this in a generalized manner. Okay, so I'm starting with 1 into 1, and then I add 1 into 2. After this I add 2 into 2, and we go so on till I go to n minus 1, and I add and I multiply n into this, and then I add in n into n. Okay, do you see? This is a generalized pattern that I can see in this type of questions. Okay, now how are we going to solve this? We are going to solve this in two different ways. We are going to split this equation in two different equations. The first one will be 1 into 1 plus 2 into 2 plus 3 into 3, and so on till we get to n into n. Okay, this is the first equation we have, and we are going to add this with the other equation we have, which will be 1 into 2 plus 2 into 3 plus, and so on till we reach n minus 1 into n. Okay, so this is what we have reached. We have made two different equations, and now we can solve this. Now let's just first solve this part. This is the easier part in this. Okay, so how are we going to solve this? What we are going to do is we are going to write it in a normal method first. It is 1 square plus 2 square plus 3 square and so on till n square. Okay, now what is the formula for finding n square? For the sum of first n natural, the square of first n natural terms. Okay, it is n into n plus 1 into 2n plus 1 by 6. Okay, divided by 6. Okay, so this is a formula that is being used for this, and it's a very easy thing. Everyone should know this. Okay, and okay, let me just teach you a few more things if there is some space. Yeah, okay, so if we are going to, I'm just going to teach you some basics of maths. If we go to 1 plus 2 plus 3 and so on till n, the sum is n into n plus 1 by 2. Okay, if we do it for 1 square plus 2 square plus 3 square and so on till n square, then the answer will becomes n into n plus 1. Okay, I'm sorry for my handwriting. Okay, 2n plus 1 by 6. Okay, but I think you are all able to hear me, so it won't be. And if we go for cubes, 1 cube, 2 cube and so on till n cube, the answer becomes n into n plus 1 by 2 ka whole to the power 2. Okay, this is the formula for all three of these, and you should remember all of them. Okay, now back to the question. Now we have to solve this part. Okay, for this, first let's make a general equation. Have you I think everyone knows that this is the sign of summation. Okay, this is the sign of summation, and we are going to write a general formula for every r. Like, this is the general formula, but we are going to use r for it. Okay, because it looks better for me. So we are going to say what if we, for every r minus 1, we multiply it with r. Okay, where r starts with 2 and ends with n. Okay, or okay, let's just I think it will be a bit more difficult for you to understand this, because yeah, no, because it will be a bit difficult to get the summation. So okay, let's just do something different. Okay, let's not find this. Okay, wait, I think I okay, let's just let's just make it a bit easier now. Let's just remove this, and this. Yeah, so what we are going to do, we are going to add it, like, and we are going with star r to this to n minus 1. Okay, so we are going to start with r being r, and then we are going to multiply it with till n minus 1. Now what we are going to do is we are going to add we are going to separate these two parts. Okay, right now they're in multiplication. Now we are going to change it. What we are going to do, we are going to write it as r square plus r. Okay, now we know the formula of first n terms and n square terms, and we know the first sum of first n terms. Okay, now what we are going to do, we are going to use our formula, but you have to remember that I am changing n minus 1 n for n minus in this question. Okay, so we are going to write n minus 1 n minus 1 into n into 2n minus 2n minus 2 plus 1, that is minus 1. Okay, by 6 plus n minus 1 into n by 2. Okay, I have told you the formula for this. The formula for this was what? N into n plus 1 by 2, right? So I have substituted n for n minus 1. Okay. Now what we are going to do, we are going to add all three of them. I would suggest all of you to first add all of them before writing it in the code, because it will become really easy. Now, okay. So let's just first, I think first we should add both of them so it becomes more easier. So it will become n minus, I'm taking in for these two, okay, for these two I'm taking n minus 1 into n common, okay. And what I'm going to do is I'm going to write 2n minus 1 here, and I'm going to take the LCM for both of them, that is equal to 6, and here, so there here will be 3. Now the answer we will get from here is, if you add, there will be 2 here, so we will get what, 2n plus 2 into n into n minus 1 by 6. And if we want to do better, we are going to write it as 1, and we are going to write it as 3. Okay, or we could have done it later, it won't have mattered. Now we are going to add this with this. Okay, what is here, n into n plus 1, here we have n into n plus 1, so we are going to take n into n plus 1 as common, n into n plus 1 common. Okay, and what we are going to have here, we have n minus 1 by 3, and what we have here is 2n plus 1 plus में 2n plus 1 by 2 by 6, sorry. Okay, we have these two things. Now what we have to do, we have to solve this. So here 6 will be in the base, here there will be 2n minus 2, okay, plus 2n plus 1. Okay, so what will we get is n into n plus 1 into 4n minus 1 by 6. Okay, so we have our formula. This is the formula in order to, that we need in order to get the answer. Now, okay, so we have the formula, just wait a second. Yeah, okay, okay, if we did it the normal way, then also we would have gotten the same thing. Okay, yeah, because no matter what we do, we will get the same answer, because if we have done it taking r is equal to 2 and then putting n minus 1 n here, then we will have to minus the 1 from there. Okay, so it would have led to the same thing, but it doesn't really matter. So now we have our formula. Now the more difficult thing to understand right now is something called modular arithmetic. Okay, modular arithmetic. Okay, now what modular arithmetic is that if we have, look, okay, I will explain it with the most basic example. If we have a into b, okay, and we take a mod of this with a number called m. Okay, we take the mod of this with m. So what will be the answer? No, I think all of you know what mod does. Okay, if we have a number called, like if we say we have a number 5, okay, we are taking the mod with 5. So what will it do? It will reduce our range of the answers from being like infinity to being from 0 to 4. Okay, our answers will only lie in these 4 digits. This is what mod does. Like if we take 11 mod 5, okay, mod in general is just a remainder. Okay, it's just remainder. So for 5, the maximum remainder we can have is 4. Okay, it's like that. So if we have to take a mod of multiplying two numbers, the mod of it will be a mod b, because a can be greater than m. So we are going to take the mod of a, multiplied by, we are going to take the mod of b, and after this there can be such that both of the multiplication of both of them lead to a value greater than m. So we are going to take a mod of this again. Okay, This is what we call modular arithmetic, and it is taking mod for multiplication. Now we are going to take mod for division. Okay, for division there is just one really important thing that you have to understand. Okay, uh, the most important thing that you have to understand is that for if you want to take the mod of b, okay, the mod of b is not the same as all the other numbers. The for division, I am not saying b, just for division. For divisional cases, the mod is a bit different. Okay, for divisional case we need to find a number called b inverse, which is actually equal to b of m minus 2. Okay, it will take a lot of time for to be able to be able to discuss and make you understand why this is true. So I will provide you a link in the description so you can study it online. Okay, this is really time taking. Now this is what you have to remember, that the inverse of b is this, and you cannot directly take a mod of division as you can take a mod of multiplication. Okay, and the other thing you have to remember is that GCD of b comma m should always be 1. If it is not 1, then inverse of, then if not 1, if the GCD of it is not 1, then b inverse does not exist. Okay, this is a very important thing that you should all know. Now there's nothing much for us to do. We just have to code the entire thing. Okay, where is the, yeah, okay, see, okay, and yeah, one more thing I really forgot to tell everyone is that we have to multiply the formula that we are getting, this formula we have to multiply it with 2022 in the end. Okay, we have to multiply it with this number. Okay, yeah, multiply. Yeah, so I will show you my code. So first what we are doing is we are taking the result. Okay, this is the formula that we made, guys. Okay, so what we have done is we have taken the mod of n. Okay, I will just write it here. Okay, first we have taken the mod of n. Okay, taken the mod of m, then we have multiplied it with the mod of n. We took out n plus 1 mod m, then we took another mod, then we did 4n minus 1, and we took a mod of this. Okay, we took a mod of this. After this, what we did here, okay, this is the thing that I have, this is the formula we have. And okay, after this what we have to do is we have to multiply it with the value of what we have, a number below, what, 6. We have 6 below, so we have to multiply it with 6 raised to power m minus 2, and we have to take a mod of it with m. Okay, you might face issues here because when you first try it takes a lot of efforts, and the implementation of this might be difficult for some people. Okay, after we do all of this, we have to again take the mod of the whole thing. Okay, we have to again take the mod of the whole thing. Okay, now let me show you the code. See, we have taken the mod of n here, then n plus 1, then 4 and this, and then this I have written k here. Now what is k? K here is the power of okay, k here is the power of 6 is 6 raised to power m minus 2. Okay, k is this, and then we have taken the mod of the result we have gotten, and then we have multiplied it with 2022 and taken a mod again. Here mod is 10 raised to power 9 plus 7. If you don't know, 10 raised to power 9 plus 7 is a 32-bit prime number, and it is one of the biggest prime numbers, so it helps us find our answers in 32 bits, which helps in the online questions, because it reduces the workload of the online judges. Okay, So here it's just binary exponentiation formula we have used to find the power of a raised to power m minus 2. We have also used modulus here because these power can overflow in int, and you should, that's why you should use long long. Okay, I use ll as long long, so just check that. Okay, once. Now this will give you the answer. I think we should just try the try the things we have already given here. Okay, and yeah, so we are getting all of the answers, and I have already submitted ones and it is working. So I hope you all enjoyed the video because this was a really good question, and I hope every one of you try this once and yeah, give it a shot. And actually, first try the question and then watch the video. I will put the question in the link below, and I hope you all enjoy the video. Thank you so much, and that's it for today.